Two massive steel legs climbed above St. Louis slowly. As workers climbed, the gap between structures narrowed. Higher and higher, both curved legs moved closer together, but closing that final gap created enormous problems. Workers would hang hundreds of feet above ground. Wind could move equipment during critical construction operations. Temperature could make the massive steel structure shift. Even tiny changes threatened the final connection. The entire project depended upon one precisely positioned section. One mistake could leave both legs dangerously misaligned. So how did workers finally close Gateway Arch? Tell us where you're watching from before we begin. Gateway Arch began with foundations deep beneath St. Louis. Engineers designed two legs rising from opposite directions. Neither leg could depend upon the other initially. Workers therefore constructed both sides as separate structures. Massive triangular steel sections arrived at the construction site. Each section followed the arch's carefully calculated curvature. Crews lifted these pieces using specialized climbing cranes. Workers secured one completed section before raising another. The cranes climbed higher as each leg advanced. New sections became progressively smaller toward the summit, yet their placement became increasingly important with height. Small alignment errors could multiply across the structure. Engineers constantly measured both rising legs during construction. Surveyors checked angles, positions, and structural movement repeatedly. Each measurement compared actual positions against planned geometry. Crews made adjustments before installing subsequent steel sections. Inside each leg, workers built through narrow spaces. The structure gradually narrowed as workers climbed upward. Tools and materials traveled through temporary lifting systems. Construction platforms surrounded active sections at dangerous heights. The two legs appeared almost identical from ground level. Their paths, however, followed opposite sides of geometry. Both needed reaching one exact meeting point. That invisible target existed hundreds of feet overhead. Workers could not simply build one leg first. The opposite structure needed rising at similar stages. Uneven progress could complicate the overall construction sequence. Engineers therefore coordinated work across both sides carefully. Concrete also played an important role inside sections. Workers placed it strategically while the arch continued rising. This added weight and strengthened completed structural portions. Each stage followed calculations balancing weight and geometry. As height increased, construction became increasingly demanding. Wind conditions affected lifting operations around exposed platforms. Workers sometimes paused when conditions became especially dangerous, yet progress continued whenever weather allowed safe operations. The climbing cranes became essential to the project. Each crane lifted materials for its respective rising leg. After installation, the crane itself moved upward. This unusual system allowed construction without towering external cranes. From below, the arch seemed to grow gradually. From above, workers faced an entirely different reality. They balanced equipment across increasingly narrow construction spaces. Steel sections arrived beside workers suspended high overhead. Communication connected crews working on opposite rising legs. Measurements had to remain synchronized throughout construction progress. A problem discovered on one side affected another. Engineers therefore monitored both structures as one system. The closer the legs moved, greater accuracy became necessary. Early adjustments could still correct minor alignment differences. Near the summit, however, available correction became limited. The structure was approaching its most dangerous moment. Both legs now pointed toward an invisible destination. Engineers knew exactly where they should meet. Workers continued lifting sections toward that calculated point, but mathematics could not control changing environmental conditions. The final gap was slowly becoming the project's greatest challenge. As the arch climbed higher, temperatures became increasingly important. Steel expanded whenever sunlight warmed its massive surface. Cooler conditions caused those same structural elements contracting. These changes could alter alignment between both rising legs. Normally, thermal movement might seem relatively insignificant. Gateway Arch, however, stretched hundreds of feet skyward. Small changes below could create larger differences above. Engineers therefore watched environmental conditions alongside structural measurements. One side could receive more sunlight than another. That uneven heating created different expansion across both legs. As temperatures changed, their positions could shift slightly. Near completion, Slight movement became a serious concern. Surveyors repeatedly measured positions throughout the construction process. Their instruments tracked angles, distances, and changing locations precisely. Engineers compared measurements against the arch's planned geometry. Unexpected differences required investigation before additional construction continued. Workers also needed carefully timed installation procedures. Some operations depended upon specific temperature conditions occurring. Construction schedules sometimes adjusted around changing weather patterns. Engineers wanted both legs approaching their planned positions. The final connection demanded particularly careful environmental monitoring. Both sides needed aligning closely enough for closure. A shifting structure could complicate the keystone installation. Workers therefore monitored conditions before attempting critical operations. Temperature was not the only environmental concern either. Wind pushed against exposed workers and equipment constantly. Strong gusts could affect suspended loads during lifting. Rain also created slippery and dangerous working platforms. Yet temperature presented an unusually invisible engineering challenge. Workers could see wind moving ropes and equipment. They could feel rain across exposed construction platforms. Steel movement, however, happened quietly inside the structure. That made measurements absolutely essential during final construction. Engineers could not simply trust visual alignment alone. Survey instruments revealed differences workers could barely perceive. Those measurements guided decisions throughout the final approach. The final section would need extraordinary positioning accuracy. It could not simply be forced into place. Both rising legs had to meet correctly beforehand. Any significant mismatch could complicate the entire connection. Workers faced this challenge hundreds of feet overhead. Below them, St. Louis continued its ordinary daily life. Above, nothing existed except open sky and steel. The final construction environment became increasingly exposed and unforgiving. For more forgotten engineering stories, subscribe to continue. These incredible projects reveal how workers solved impossible problems. As completion approached, the remaining gap became smaller. Engineers knew thermal conditions could change that distance. The arch was behaving like an enormous measuring instrument. Weather could subtly influence its final dimensions. Workers therefore waited for carefully selected working conditions. Timing became part of the engineering solution itself. Measurements were checked again before lifting critical sections. Communication connected surveyors, engineers, crane operators, and workers. The structure was now close to becoming complete, yet its two legs still remained separate structures. Between them waited the final carefully designed section. That piece would transform two rising towers permanently. But reaching the summit created another immediate danger. Workers now operated hundreds of feet above ground. The height made simple tasks increasingly complicated and dangerous. Narrow platforms offered little protection from sudden conditions. The final engineering challenge was approaching its climax. Steel could move, wind could interfere, and heights threatened. Workers would soon face all those dangers together. As construction climbed higher, workers entered thinner spaces. The arch narrowed dramatically as both legs approached. Platforms became smaller, while open air surrounded workers. Beneath them, St. Louis stretched far below their feet. At these heights, simple movements required greater attention. Tools could not be dropped without serious consequences. Heavy equipment needed secure handling during every operation. Workers carefully moved materials through narrow interior spaces. The climbing cranes continued lifting sections toward the summit. Each load traveled upward beside exposed workers. Crews guided massive pieces into their exact positions. Strong ropes prevented dangerous swinging during difficult lifts. Wind created constant problems around the unfinished structure. Gusts could suddenly move suspended materials sideways. Workers watched conditions before beginning sensitive operations. Dangerous weather sometimes forced construction activities to pause. Inside the arch, conditions remained extremely confined. The legs became narrower as elevation increased. Workers climbed through spaces surrounding structural components. Ladders connected different levels throughout the unfinished monument. Communication became harder between workers and ground crews. Distance weakened ordinary shouted instructions during noisy operations. Signals helped coordinate movements between different construction teams. Timing mattered whenever cranes raised heavy structural sections. The psychological challenge was equally difficult for workers. Hundreds of feet separated them from solid ground. Narrow platforms offered little room for hesitation, yet construction tasks continued with disciplined routine. Workers inspected connections before releasing suspended sections. Bolts and welds secured completed pieces permanently. Each connection had to withstand enormous structural forces. Engineers checked work before allowing additional sections upward. The upper sections required increasingly careful positioning. There was less space for correcting mistakes. Workers could not easily reposition already secured pieces. A small error could complicate later construction operations. Meanwhile, both legs continued moving toward each other. The remaining distance became visibly smaller from below. Visitors could finally imagine the monument's complete shape. Workers, however, saw the narrowing gap differently. For them, that gap represented the project's greatest risk. Two enormous structures needed meeting at one point. Their curves had to align despite environmental movement. Nothing about the final connection could remain approximate. Crane operators worked from increasingly elevated positions. Their machines rose alongside the growing steel structure. Each lift brought equipment closer toward open sky. The construction site itself gradually disappeared below them. The final sections demanded coordination across multiple locations. Workers above waited while crews prepared loads below. Engineers reviewed measurements before authorizing critical installations. Surveyors continued monitoring both legs during construction. Height changed how long ordinary operations could take. Moving equipment upward required additional time and planning. Reaching workers with replacement materials became increasingly difficult. Even routine repairs could delay the construction sequence. Yet workers continued climbing toward the summit daily. Their work transformed calculations into visible steel overhead. Each new section reduced the distance between legs. The arch was finally approaching its historic closing moment. Soon workers would face the narrowest remaining gap. That final opening would determine the project's success. But fitting the last section required more calculations. It required perfect timing between steel, temperature, and gravity. The gateway arch now appears perfectly seamless from below. Workers once faced unimaginable dangers closing its final gap. Steel, wind, temperature, and gravity threatened their success. Yet careful engineering finally brought both massive legs together. Subscribe for more forgotten construction stories from history.